All right, we are back. It is COMP3025 in the winter 2017 semester at Georgian and mobile and pervasive computing. And today we're going to learn a little bit more about TypeScript classes. I want to focus on how to create your own classes and how to import stuff a little bit more. We need to know how to do this because when we combine things with Angular 2, you need to know TypeScript and you need to know it pretty well. So one of the things I like, an exercise that I want to do today with you to learn TypeScript a little more is to make a small game, right? We're going to do it with purely with JavaScript technologies. We're going to use some support libraries to do that. We're going to use the Create.js framework. So if you want to look, or actually it's an API, a library. There's four, Create.js has four libraries that they use. Easel.js that uses the canvas element on the page, as well as Tween.js, which animates. So you can actually do some small animation and movement across the screen if you need to do that. And actually it's really good for things like easing in and out and a bunch of other functions that are built in. Sound.js that generates sound, and Preload.js that preloads all your images and sound assets. Right, it's really, really cool little library. This library, we can't use it all this semester, of course, but it is one of the choices you have when you're creating if you're going to make a mobile game purely with web technologies. It's not a bad solution for you. What we're going to be doing is we're going to be using part of this library just to get things moving on the screen. And we're going to use this as a vehicle to learn TypeScript because we need to make a custom class. We're going to make a custom player class. The player class is going to control a sprite on the screen, right? And we're going to bring that into a closure with JavaScript. So this is the reason for this. This is the underlying motive behind it, right? Because if I just did a class like the person class or the greeter class that you've seen lots and lots of times, it doesn't resonate. You don't understand how it's being used. But once we create our own class, we as objects on the screen, you'll figure things out a little bit more, and it'll be more intuitive for you. Now, there's a bit of setup for this one. So if you're watching from home, and I see some of you are here, but most of you are not, which is totally cool, we need to download some tools. Now, the assumption is, I'm just going to pull up my editor here. I'm going to clear my terminal. The assumption is, again, that you have access to Node. So your Node should work, NPM should work, Bower should work. These are all things that you should have at your fingertips for this example. Right? And also, please install TypeScript if you haven't had a chance to do that already. So in order for you to install TypeScript, you need to do something like this. npm install TypeScript -g, all right? And what this will do is install the TypeScript library. Without TypeScript, again, it becomes hard to do Ionic 2 because it incorporates TypeScript in everything it does. Okay, so as you can see, I got 2.15. To test TypeScript, if you got the right library, it's npm tsc -v. That's the way you can test TypeScript that it's working. Okay, so those are all the things you need to get going. Okay. If you don't have one of these libraries or any of these libraries, and especially if you're using a Windows machine, it could take you a little bit of time to set that all up, right? And one of the things that I recommend to you, if you're just doing this as the exercise, is use the cloud. The C9 development environment, the Cloud 9, because you don't have to worry about configuring your console, right? Your command prompt. You don't have to do that. All you need to do is you can just install everything you need within the small terminal window and work, as if everything is mostly configured, especially Git, which is what I'm going to be using. In order for me to start off, I'm going to make a GitHub repo. So I'm going to go to GitHub, and this is of course, what we always do. And my GitHub repo that I'm going to make is going to be called COMP3025, winter 2017, and it's lesson 4, right? There you go. So there's my GitHub repo. I need to connect to it, and I need a library for this to happen. I'm just preparing. This is all prep for me. So forgive me if I'm going to go fast, but we don't have a lot of time. And I think, Mackenzie, you were complaining that my desktop was really messy, so I cleaned it up just for you. Let's make a new folder. So a new folder on the desktop. I'm going to call this folder, we're going to call this our game folder, right? So this is we're going to call it game, right? You can also call it, if you really want to, if you're following along with me, you can call it the name of the lesson today, which is COMP3025 lesson 4, which might make sense for me a little bit more. In the folder is now blank. I'm going to just use Visual Studio Code and drag and drop the folder into Visual Studio Code. You can also use other editors if you feel like it. But I find Visual Studio Code is great for code hinting and code coloring for TypeScript especially, and Node. Okay, so I've got my folder. I'm going to create a few items. I'm going to create my folder structure first because that's what I do. And I expect you to do the same thing when it comes to your. So here we're going to make an assets folder. This may change, by the way. When I make assets here on PhoneGap, and if you're using Cordova, sometimes it's the resources folder you need to create. Just let you know, it looks for certain folders. So later on, if we ever convert this game into, or the parts of this game, into something that's mobile compatible with Cordova or PhoneGap, we may have to change the name of this from assets to resources. But at the end of the day, it doesn't matter. Okay, then the next one is, oops. The next one that we're going to make is content for our CSS. I'm not going to have a lot of CSS here. And the next one, of course, is going to be scripts. That's where everything is going to live, our scripts, right? I'm going to create our scripts in a certain way today. Inside of our scripts library, I'm going to make a new folder. One of them is going to be called core. We're going to have our core library. I'm doing this on purpose because I want to be able to make it a little more complex for you, so you understand how to navigate through the JavaScript folders and namespaces and everything else. Okay, so this is our core game is going to live in here, right? We're also going to make another folder in our scripts folder, another new folder, and we're going to call that objects. Objects, they're going to live in here. So my plane, any kind of enemies, all that kind of stuff, that's where they're going to live, right? And then also, we don't have it yet, but we need to get our libraries in here. So that's where it's going to be. It's going to be under lib. But we're not going to make that folder. It's going to make it for us. Okay, we're setting up a TypeScript project and a Bower project at the same time, right? So what I need to do for this one right now is I want to set up our Bower RC. So in the root of our folder, I want to make a new file. It's called the .bower RC file. We've done this before. And what we're going to do here is put two curly braces and control space. And we're looking at the directory structure. And instead of Bower components, we're going to point to scripts where our lib folder is going to be created whenever we download anything from Bower, right? Typical folder structure. Okay, we're getting there. What I need to do now is I want to put a placeholder for my index.html because that's going to be our manifest for the entire project. So a new file, index.html, right? And in our index.html, we're going to set up our basic project. So again, we're going to put a doc type. And inside here, we're going to put, I'm going to use shorthand here, Emmet. So it's going to be an HTML. Inside HTML, we're going to have a head. And we're also going to have a body, right? And the head is going to have a couple of things, a title for sure, where we're going to put the name of our program, our game today. Well, I can put COMP3025. And then it's going to be lesson. That's fine. And also some meta tags that we need for responsive design. So one of them, of course, is going to be our character set meta tag, really quickly, all the same stuff we've seen before with UTF-8. And the other one is going to be our meta tag for our viewport, right? Which we need. So name is equal to viewport, and then content is equal to width, which is equal to device dash width, and then initial scale is equal to 1. This should be a part of all your projects now. And also, I want to say user dash scalable, because we're making a mobile game, is equal to no. I want to put kind of put that in there as well. We don't want it to be user scalable. Right, so the user can't pinch and zoom in our game, right? So that would mess things up. All right, so user scalable no, initial scale 1, device width is equal to device dash width. Cool. We're going to make a CSS section. This is just placeholder stuff. CSS section, just setup. And then at the bottom, we're going to also have an area that's going to be our scripts section. Scripts section. All right, so we're just sectioning off our document. We also need some kind of, I'm going to kind of put it inside of a couple of a div tag, right, as an example. And inside of our div tag, we're going to have a canvas tag with an ID of canvas. And I'm also going to have some initial parameters. I'm going to have a width parameter. which I'm going to make 640 pixels. Well, actually, you know what? Let's make it so it's mobile. We'll make it 20 pixels, right? And then our height parameter, which is going to be 240 pixels. Kind of our width and height. And if you press tab, you get all that, right? So some basic setup so far, just a basic structure for our page. We need something to hang our project on, if you will. And this is going to be our structure for the project so far. Very, very high level. Again, we're going to tap into, for those of you who've never used Canvas before, it's a great tool. We can use Canvas to rasterize images, especially things like ads, special effects. The canvas doesn't have to be visible. The borders of the canvas, you can make it invisible. And you can also stretch the canvas to fit any kind of viewport, which is kind of neat. The only negative about the canvas is you have to really, when it comes to responsive design, you have to think about it as the canvas is simply pixels. And that means you have to create your own responsiveness for anything you put on there. Because right now it's going to be absolute positioning, right? Which is contrary to what we normally do with responsive design, right? On the plus side, when you do absolute positioning, you can scale, right? So if you're scaling to different screen sizes, it's a lot easier. Okay, and this is what we're going to be doing a little bit more. So Canvas is where the game or the actual application in this case is going to live, right? This is the application. Now we need to have libraries to make all this go, and I need to have a couple things that I want to do. First of all, I'm going to have my own CSS file, and it's going to be probably in something called, and I'm just going to put this the folders in this kind of format. So it's going to be under content, right? And then it's going to be a game.css. I don't have it yet, but I will add it. Right? So that's going to be our own custom CSS. And then we're going to have a custom script for our game. So our game is going to live in something called game.js, right? So we're going to do the same thing. We're going to have a script. And then inside of our script, we're going to have a source with a path of ./scripts. And then it's going to be core, because it's going to live in the core library. And then game.js. We can't put game.ts, and you're going to see that a lot. We might have a TS folder, a TS file. But for those people who remember TypeScript, TS must convert to JS because TypeScript is not interpreted by any browser. It's only JavaScript that's interpreted, right? So we convert from TypeScript to JavaScript with some kind of transpilot, which is the TypeScript library you just install with NPM, right? So that's the one thing we have to do. So it's going to be a JS file, and this is where our game is going to live. So we're going to further do a scripts section. We're going to say our game scripts. This is where they're going to live. So we have our game scripts here, and we have our scripts section here for our scripts library, right? Up here. This is where our scripts libraries are going to live, right? Setting up right now so we can see how it looks. So you guys should have right now this. The only thing I would probably add is under the HTML tag, language being English, if you want to be really a stickler, around here. Right? Are you with me? And I'm asking this question because as we go, if you don't have this piece done, then it might affect the way your game will look and feel and all that kind of stuff. All right, I think we've got most of everything we need to start our Bower initialization, right? And the reason why I'm saying that is because before I put things up on GitHub, I want to have Bower ready. So it's got the Bower RC, which I'm going to need, right? As well as anything else. Let's go back to our solution. So we got our Bower RC. I'm going to add in a gitignore file. So here's .gitignore. And right now, all I want to do is if there's anything like node modules, for whatever reason, if it gets added in, I don't want to save this online at all. I probably won't need any node modules, but just in case, I want to kind of mention this. Anything else you want to exclude is going to be in your gitignore file. Next, it's going to be a TypeScript project, so I know I'm going to have a tsconfig.json file, right? So that's another thing. So TypeScript, we have to define how TypeScript transpiles from JavaScript from TypeScript to JavaScript, because compiled language, right? It compiles on top of JavaScript itself, right? So we need to have a tsconfig. This is the TypeScript configuration, tsconfig.json file. And the options on tsconfig.json, okay, if we're going to add it in, is the first one that I want you to put in is if I press Control Space, right? If you look at compiler options, that's the one I want to put in. And if I press Enter, it's going to give me my compiler options object. right? Again, if you're with me, you'll see that what we're doing is we're setting up the project still. It's all set up, right? And it's good to do it from scratch so you understand how everything fits together. So we can kind of decouple or deconstruct what I'm doing later on. Control space, again, we're going to look at the target, right? And I'm going to target, even though ECMAScript 6 is good, I'm going to target ECMAScript 5 for compatibility reasons. From there, I'm also going to talk about the type of modules that I want. I'm going to use CommonJS as the most common type of module structure. And then I'm going to select source maps. I want to put source maps as true. What are source maps and why do I need them for JavaScript? This is kind of a web course in a little bit. Anybody know? Why do I need source maps? No one knows why I need source maps? It's for debugging, actually. Source maps, especially when it comes to TypeScript. If I get a TypeScript source map, and if you notice, sometimes you pull down something like jQuery, and when you pull down jQuery, it comes with a map file. It helps us debug JavaScript. It actually tells us the line where there's a problem, right? So that's really, really important. That's why I use source maps for debugging. Okay, so my compiler options are good. I'm saving that. So I've got my tsconfig.json. And now what I need is my Bower JSON file. I can create it manually, but I'm going to use this terminal window, or in your case, the command prompt to do it. Right? I have to be in the right folder. So I'm just going to close this off. If you have it in some other folder, make sure that you're in the right folder here, right? So I'm going to kind of go in here first, right-click, and open in terminal, or open in command prompt for you, right? If you're a Windows person, most people are. What I want to do here is I want to specify, I want to start kicking off my Git repository first before I do my bower.json file, and I'll show you why. So I'm going to say git init, initialization, git add dot for adding everything, git commit -m, initial commit, all the regular stuff that we normally do. Again, we should be using at this point in time in this semester for you guys, GitHub or some kind of version control should be with everything that you do. Any project you do should include it. If you don't include it, or even if the professor hasn't asked for it, you should do it, all right? Because this is good practice for you at this point. Okay, so we've got our local a repository here, but we need to connect it remotely. And this is going to be our first commit before we do Bower, and there's a reason for it. So we know our last two lines are the things that we need to connect the remote and to push to master. So here it is. I'm just going to paste it in here and then press enter. And if you've set up your terminal window correctly, you shouldn't have a problem with your credentials or anything else. I've pushed it to Git. So now if you can't follow along, or if you're late coming in, because I went too fast, you can always go to my Git repository now. So up online, GitHub repository. If you go to Georgian College /COMP3025, W2017, lesson 4, you can check to see if what I have compared to what you have. Right? So make sure that you have what I have right now. Notice that even though I uploaded everything to GitHub, there are no folders yet. The folders don't exist because there was nothing inside of them. Right? Again, this is my initial commit. I'm just creating my first repository. Right? Okay, so now that I've got that done, I'm ready to go with Bower. And I'll show you why I did this. Right? So I'm going to clear the screen. Bower init this time. And Bower init is going to recognize a couple things. Project name, I'm going to put lowercase just because it's more compatible with everything else. And then the description, which is a, we're going to say TypeScript demo with create.js. That's what this thing's all about. And my main file is going to be my index.html. It should be something like that, or index.js. Keywords, again, is going to be JavaScript. You need to know in JavaScript, TypeScript. Again, you can put whatever keywords you want in here if you really want to stick with create.js. I'm just letting you catch up. Those kind of things are really important. Notice it fills in my author information because of my GitHub, as well as my license and my homepage, which is the GitHub link, right? And I'm just going to select everything as yes, yes, yes. So it kind of did all this already for me. It kind of created my Bower JSON file. And I want my Bower JSON file to be in here because what we're going to be doing is we're going to be installing modules in here, front-end dependencies, and we're going to get them from Bower. So I want to keep track of anything that I download and install. Looks good. Yes, it does. And I'm ready for the next step. So here's my bower.json file. It's right here in my project now, which is good. And now I'm going to start getting ready to download and install other things. First things first with this one. I want to grab all my libraries. Remember I talked about Create.js has 4 parts. There's Easel.js, there's Tween.js, there's Sound.js, and there's Preload.js. Those are the 4 libraries. I could, like I said before, go to these libraries and go to each one of them and download each one of them separately and install them by hand, but that doesn't make any sense. I want Bower to do it all for me, to make it nice and simple for me, right? Because we just want to do this demonstration here. So how do we do that? Bower install, and we're going to start typing Easel.js, right? Space Tween.js, space Sound.js, space Preload.js, -- save, because it's part of our project. So you're going to install all those libraries all at once, and they're going to go into the scripts lib folder, which is totally important for them to go into that folder because we want to kind of organize our files. Not with me. You're still good? You're with me?
I'll be fine. Yeah.
Anyone not with me? Guys, please keep up because this is going to be where I might lose you. All right, so I install everything, and if I did everything correctly, Bower is going to grab all my files, my libraries, and all the dependencies, and bring them inside of my scripts lib folder. Okay, scripts lib. It's doing a really nice job of getting everything. Right? It's taking its nice time, which is unusually weird that it's giving me progress for all my downloaded files, my sound. This is not normal. Normally it's like lickety split. It gets everything. But maybe everyone's doing it at the same time. All right, so I've got all my libraries, and it gives me my library version numbers. And if I go back to my project, you can see now that in here I've got all my versions of all my libraries, and inside my scripts lib, I've got all my libraries nicely. This is what your folder should look like. Now, you might be tempted to remove lib and put that inside of your gitignore file, but I caution you against this because a lot of, especially with Cordova and PhoneGap, all the libraries that you're using must be part of the project, right? Please do not use CDNs, right, and anything like that for a native project. It will not work properly, right? So if I ever convert this to a Cordova project, you need to have these libraries here inside our folders. All right, we've got our libraries, but we need, this is the TypeScript part, right? I need to do more TypeScript, okay? And I need code hinting before I do any kind of coding, I want code hinting for our libraries, which means I need type definition files. Does anyone not know what a type definition file is? We talked about TypeScript before, so you guys should have an idea of what it is. Well, as a recap, if I look at a type definition file for TypeScript, if I was to look that up, so if I said TypeScript, type definition, right? What that is. If I look at what that is, it'll give you a great description of what it is. It's kind of declarations is what it is. You can create your own, file and so on. But what we do is, what it does is, and this doesn't really tell you much, it kind of describes the libraries that you're kind of installing into your applications. An example of that would be, we're having these 4 libraries, but unless I put some kind of code hinting, I can't get to the classes. I won't get any kind of tooling at all for the library, so it won't tell me if I'm doing it wrong or if I'm missing something or if it has to be a capital here or a lowercase there or what the requirements are for the library. So I want to install that code hinting up front. And just from the basics, TypeScript allows us, that's one thing that TypeScript gives us, code hinting. But in order for me to get my code hinting, I need to install some NPM modules. This is the next part, right? And if I'm going to install NPM modules, what do I need? I need a package.json file, even though my project is not a node project. So in order for me to do that, I'm going to say npm init. Here's my npm init. I need to make this package as well. So COMP3025, W2017, lesson 4, right? And it's version 1, sure. My description, again, is the same as before, which is our TypeScript demo with Create.js. Entry point is index.js. I'll leave that alone. It's not really true. My Git repository is there. My keywords, we kind of put them in before I leave them blank. My author is me. Right? You can put you. License is the way it is. I'm going to accept that. It's just a basic, I need this basic package.json file in order for me to be able to save my type definitions as development dependencies. Now, they're not dependencies. I don't need my type definitions to build my project. I need my type definitions in order for me to support my development. So they are development dependencies. So it's going to be a minus save minus dev when I do that. That's the switch that I'm going to use with npm. Let me show you what I mean. So now here's how you install type definitions. They go like this: npm install @types / and the name of your type. In this case, I want to install easel.js. And if it doesn't work, it'll tell you. So here's easel.js, and then minus save minus dev for a development dependency, not a dependency. Press enter. If it finds it, it will install it. And here's an example of what it does. It finds easel.js. It knows that it needs another dependency called create.jslib, then another one for tween.js. Those are the dependencies. And these are just type definition libraries to give us code hinting for our libraries. And by the way, when you actually look at an Ionic application, which we're going to do later on today, you're going to see that they have all these code definitions for Angular and Ionic built into them. But I want you, again, to just decompile all this stuff on your own to understand how everything's built out. Okay, here's other ones. npm install @types. And we're going to go into, I'll install tween.js manually. So I'll show you what the difference is. So here's tween.js. And again, minus save minus dev, because it's a development dependency and it's not a project dependency. I'll do the same thing with @types sound.js, minus save minus dev as a development dependency. And then just to be sure, even though it load or preload anyway, I'll load it manually anyway, either way. So just to show you, npm install @types. That's how you get type definition libraries for npm for TypeScript now, which is awesome because it's way better than TSD. And then preload.js, minus save minus dev, and then press enter. So now I've got all my type definitions, and where do they appear? In my project, notice I have node modules. Remember I talked about node modules? I don't want them up, and I put that in my, I put node modules as something I don't want. Well, these are all the node modules that I don't want to be sent up to GitHub, right? So whenever you install, whenever you kind of run my project, and now that I'm going to put it up on GitHub, please do an npm install, which will install these node modules. Okay, otherwise your project will not work like mine. So here's dependencies for again we're looking at barra.json dependencies. But if I look at my package.json, you can see that I've got something called development dependencies in here, which are just to help me build my project, not as project dependencies. My project will run them without them. That's what development dependencies are. These just help me for code hinting and that kind of stuff. Are we good? Okay. Now look, I have 69 files that I need to put up on GitHub, and I think this is a great place to put my GitHub link up. Right. So I'm going to do that again. This time I'm going to use the integrated Git tool that's built into here. I'm going to go here. I'm going to notice on changes there I can actually click the plus next to changes or any one of these files. These are all updates or adds. So I'm going to click this one. This is like doing a git add dot. And in here I'm going to do something like added create.js libraries and definitions. There we go. I'm going to check mark. I'm going to go the ellipses, and because I've defined a remote, I can do push, which is going to push everything on GitHub. So if you're slow, if you're late to come in, right, as an example, and you want to kind of catch up to me, don't type this all by hand. Grab my repo. Make sure you do an npm install, and then you're good to go. Now we need something to tell everybody when someone's coming to my repository that they need to do an npm install for me to kick it off, which means I need a README file. I could do one here, a readme.md, and I'm going to do that here instead of doing it online like I normally do. So I need a readme.md in the root of my folder, right? Because that's what GitHub will read, right? So a new file, it's going to be readme.md lowercase for Markdown. My Markdown file automatically gives me a preview in Visual Studio Code. And remember that Markdown, the way it works is one hash means an H1 tag. So the name of the project, COMP3025, winter 2017. And then it gives me a preview on the right side, lesson 4. And then maybe a subtitle would be going here, which is, TypeScript. Notice that 2 hashes mean an H2 tag. TypeScript demo with create.js. And then some information, maybe the third, kind of another regular stuff, what I want to put in is I want to say, please use, right? I want to say npm install, right? In order to place type definitions, or to include, say, type definitions for as development dependencies for your project. Right, so kind of a longer line, right? But I want to highlight npm install because npm install looks like everything else, right? So that means it's kind of a command. So I want to do a couple things. One, if I want to make it look like it's code, I'm going to put backtick. I want it surrounded by backticks. Right, so there's npm install. See how the style changed, right? And then I want to kind of do 2 stars on either side, right? Which highlights that it's going to be bolded. Single star is italics. Right, so again, some little bit of Markdown today. Not too crazy, but just understanding how things work. So npm install, it tells you what it does. This file, readme.md, is only local to me. I need to put this up on GitHub in order for you guys to see it. So I could do that with the next commit. Next commit, you'll see the README file. We're almost there. We're almost in setup mode. I need to do a couple more things. One, I need to be able to set up my my game.js and all the other files I need. So under scripts, under core, I'm going to create a new file called game.ts, not JS, because I'm going to transpile this later on. Right now, it's a game.ts file. TS for TypeScript. And I'm also going to, I have to define how to transpile from, I put this in scripts, by the way, game.ts. I'm also going to put together in content a new file, which is my game.css, right? I need that too. I don't have any assets yet, but I'll give them to you in a bit. You can download them, install on your machine. Again, so it looks like a more complex project now. As we keep building it from scratch, you can see how we're putting all the piece parts, the components together to get us going. So in my game.css, I can just get rid of this now. My game.css, this is where my custom CSS goes here. I do that a lot. Oops. And in my, I'll save that. In my game.ts, it's a TypeScript file. This is where my game will be defined, right? So game script. You know, so this will be my core game script, core game script. So core game script is going to be here, right? I don't have any assets yet. So there's a couple more folders now I'm including. But my index.html doesn't work yet because I have no libraries, and I need to include them manually, right? So I got this part, I'm okay. But down here is where I need to put all my libraries. So let's put those in now. So it's going to be script. And inside my script, it's going to be source, which is going to equal to, and if I don't know the path, especially I'm going to start with easel. It's going to be easel lib, and then easel.js -0.8.2.min, the minified version. I just need this one, copy path. And I'm going to go in here and place it in. And I want to get rid of anything before the scripts because I don't want to type that in because that's going to make it so it's only working for me, not for you. So this way I'll put the ./ in front of scripts. Okay, so that's my first path, right, for easel.js. And I want you to do the same thing. If you can think about, try and do it on your own. I want to do the same thing for the others. So easel, tween, then sound, then preload. See if you can do that if you want to challenge yourself. So I'm going to put these copy and paste in here, right? So there's my 4 libraries, but it's going to be lib, and then it's going to be tween next. Notice that's tween, and it's tween instead of easel.js, it's going to be tween.js 0.6.2 because there's not 8.2. .main.js, and then there's sound, so it's lib, And then it's going to be, notice there's a Cordova audio plugin. This is what we're going to be using if we ever go and publish this game on a device. We can't use regular sound. It won't work. We need to use a Cordova plugin for that. So here's Sound.js 0.6.2. And the last one is our preloader, which always has trouble with Cordova. We're going to figure out how to use that later on when we do this another day. We'll have this project as our kickoff project if we test it again. So I'm going to change it right now. So preload.js 0.6.2. Did I make a mistake? Oh yeah, that's bad. 0.6.2. Yeah, so this should be a tween, if I'm not wrong, right? And this should be just capitals what it is, right? So this would be sound, and this will be preload. Thank you for that. That's what, otherwise it won't work. All right, so we've set up our libraries. We've got our game.js. You know, we should be golden. Let's do a small test of this thing. And the first thing we're going to do is going to go into, I'm going to go into scripts core, right? And in my game.ts file, I want to put a closure, and I want to use an IFI. So this is IFI, which stands for immediately invoked function expression, right? That's what an IFI is, which is actually a self-executing anonymous function equivalent, right? So how does it look? You guys should all know how it looks now. It's function. This is the old way. And then if I can do one of these with a semicolon at the end, anything that's inside the curly braces is in a closure, all right, right now. That's what it looks like. This is a self-executing function, right? So what I want to do here, just to make it work, I want to do console log, right? And I want to say app started, because we just have an app right now. We don't really have a game yet. Why not? We'll put game. All right, so we've got this function, but it's TS. We need to transpile it. And in order for us to kick off the transpiler with Visual Studio Code, that's why I'm using Visual Studio Code in the first place, on a PC, you need to do Control-Shift-B. On a Mac, you do Command-Shift-B. So if I do Command-Shift-B, it says that my task runner is not configured. And I'm going to configure my task runner now. By the way, once I go through this and put it up on GitHub, and if you download everything, you'll have my task runner. So if you haven't been able to keep up, it's okay. Here's my task runner, and it tells me some options. One of them is this tsconfig.json. This is a good one, but the better one is in watch mode. So that way, if anytime I change my files, it automatically transpiles from TypeScript to JavaScript immediately. So I don't have to do any kind of automation. It's just built in, which is awesome. We never had that in the beginning. So I'm going to choose this one, TypeScript with watch mode. And what it does is it creates this little default transpilation, and what it does, it uses arguments minus W, right? Minus W basically is in watch mode when you kick off your transpiler. And again, you need to kick off your transpiler one more time. You need to do Command-Shift-B or Control-Shift-B on the Mac. Now, I'll do this for you, and you'll see what happens. So Command-Shift-B for me. And what it does is it converts, watch over here, it converts my TS to JS and includes a map file. All right? Now, I'm showing you this because this is the exact process that's going to happen with your Ionic, right? And I'm slowing it down for you so you can see the process. Again, I want you to deconstruct or decouple what's going on, right, from Ionic with this process, okay? So here's my game.ts, and here's how it converts to JS. It's identical right now because I am using JavaScript, right? Now, because it's a JS file, it's a good chance that my index.html will be able to see it, right? Because this is what I'm looking for, a JS, not a TS. Okay, I'm going to save. I've got 7 changes, and I'm going to put this up to GitHub, and we're almost there in terms of our things that we need. So I'm going to say added. So again, what did we do? We configured the TypeScript. That's what we did, right? Configure TypeScript, and we're going to kind of click this and push, and you're going to see that as a commit. Again, anytime in this process, you should go up on GitHub and grab my files so you keep up with me. Because if you came in late, it's totally cool. Don't start from scratch at this point. There's no way you can catch up. Please download my files or compare what I have on GitHub with your own so you can keep up. I'm showing you this, and it's important for you to do this work because you won't understand TypeScript when we do Ionic. It will be impossible for you. You'll look at it and you'll go, why is it happening this way, right? And it's the same thing with Angular. That's why we need to do both. Okay, so I've got my basic project now, right? And I need to test it. Let's test it out. Now, for Ionic and for any kind of game that you make, you should really use some kind of mini server. And I'm going to use, I've done kind of install the server. I use light-server. That's what I use, L-I-T-E. And you can install that by going npm install light-server -g, right? Which will grab the latest version of Light server. Again, it's a small node server that runs in the background and has browser sync. So it'll kind of, anytime I update my project, my browser will be updated immediately, right? There's browser sync for you. Okay, so I'm going to clear that up. And here we are. We're going to do light-server. I have to be inside of my project files. If I press light-server and press enter, it's going to search for index.html, and we've got nothing because we haven't done anything yet. I'm just seeing if my files are working, and the best way to test that is right-click, go to inspect, and what I'm really looking for is no errors and something here. Now this is bad. It says I've got a problem. I got failed to load resources, but notice what it's failing to load, my icon, which I don't care for right now. But everything else is good because I got game started, and if I refresh, see that goes away, right? So game started is awesome. That means that it's got to my JavaScript file. It recognized, it transpiled from TypeScript to JavaScript, and I'm good to go. Please, 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 at this point, right? I ask you, join me here. Don't watch me because you're not going to get the next part. This is where it's going to fry you, your brain, right? If you haven't done this before, right? If you've done it before and you're going to watch the video later or something like that to figure it out, that's perfectly fine. But you need to do it at some point on your own because on the exam, right, there's going to be TypeScript elements. It's going to happen, right? Remember, I allow you to do whatever you want, but there might be something to do with TypeScript for some of you, especially if you're using Ionic or one of those things, and it's going to mess you up. So please don't wait to learn this stuff. Okay, I want to kind of outline just to give us a visual aid, I want to outline my canvas element. My canvas element is invisible right now. The canvas element is white, actually. That's the default color. It's the default, or it's invisible. It's transparent on the background, right? So I want to kind of give it a border, and I'm going to ask, to help me out. So I need to go into my content game.css, and in here I want to put some kind of CSS to make my canvas visible. My recommendation, of course, is targeting the canvas ID, right? So if I go ID of canvas, I'm targeting it in CSS, and now I want to put a border, right? Would you say that's correct? So a border, no one's helping me, 1 pixel, right? And let's make it so it's dotted, and then we'll make it black, right? That's the border that's going to be around. If I press save now, and I go back to my thing, you can see that this is the canvas size. Is this what I wanted? That doesn't look like 320 by, 320 by 480 to me. Does it? Is there something wrong here? Right? How come it's giving me this weird kind of size, right? First of all, let's make sure that I'm in the right proportions, right? Still looks wider than it is longer, right? Which is kind of weird. It should be longer, not wider, right? That's one thing. So 320. Remember, I asked for my canvas. Now this is what it actually physically looks like right now. This is where my game will live. It's pretty small space, right? So if I go back to my Visual Studio Code and I look at my index.html, make sure that the width is correct and the height is correct. This should be 480, not 240. So let's change that. That was a mistake. When I do that, you can see that now it's the size of the proper size, and it automatically, with browser sync, it automatically updates my code so it looks like the size of a mobile phone. That's what I wanted to get to, the proportions of a mobile phone anyway. May not be the right size. If you want this thing in the middle, how do I center it? Right? How do I center it? Margin, right? But I don't center the canvas. I'm going to center this div tag, which I'm going to call my game container. So I'm going to make an ID of game container, right? So I'm going to kind of add an ID to the div tag so I can hook into it with CSS. I can also look to the first div tag, but I'm going to look at the game container. And I want to give margin to this, right? What should my margin be? 0 auto, right? Again, remember what it is. 0 is the top and the bottom. When we use the box model, it goes around in a clock, right? So it goes top, right, bottom, left. So 0 means if I only use 2 elements, 0 is top and bottom. And then auto is right and left, right? So auto means it's going to be automatically placing it in between. Well, we have a bit of an issue. Will this actually work or do anything right now? No, because we haven't defined a border. Should we put this here for margin 0 auto or the canvas 0 auto? And my recommendation is we move this to the canvas with a margin of 0 auto and define a width of this object, right? The width of my container, my game container, should be a certain width. Like, for example, we can't put 100%. If I put 100% here, right, and this is where it gets bad, right? So width is equal to 100%. If I do this, sure, the width is 100%, but you notice that I don't define anything here, right? So width is 100% for my game container. Width's got to be the size of my screen. So viewport width is what I want to put, right? So viewport width. If I put 1 viewport width or 100% viewport width, like viewport height, there's viewport height and viewport width, right? That's kind of a of a tool, right? So I have to. This is the kind of our unit measure, right? Viewport width and viewport height. What do I put this to be 100% of viewport height or viewport width? What do I do? What do I put there? Does anyone know?
100.
Thank you. Let's see if that works. So 100 viewport width, right? Still, I'm not centering. And you can also look at it from a, if I go to the, and my elements perspective and want to see what's happening. If I kind of hover over everything, so here's my div tag. It's 100% viewport width, but I'm not getting margin. So this my div tag does take up my entire viewport, but I want to put margin over here of 0 auto, right? Here's my 0 auto, and I don't really have that, right? How do I fix it? So notice if I go to in my canvas element, here's my canvas element. You can see what it does, right? Right now it's my margin is 0 auto. I'm 1 pixel dotted, 320 by 480. My game container is my viewports there, and notice that the size is 1280 by 496 right now. So it actually is confirmed to that 100% viewport height or viewport width, right? So what do I do? Come on, guys, help me out. I want to kind of center this object over here, right? My screen. It's gonna make it more easy for me to see it. What do I do to move it over? What's the right thing to do? Come on, guys, help me, please. At least you be engaged as opposed to just watching, right? I'm gonna start asking people. Anthony, what would you do?
Are you using Bootstrap?
Nope. Can't use Bootstrap. Bootstrap, it's gonna be too heavy for Bootstrap to use, right?
Maybe like a position absolute.
Okay, but that's bad. Absolute positioning is that won't really solve my issue. I want to do margin, right? How come my margin isn't working? I'm asking for margin of auto, 0 auto. Yes.
There's nothing to the left of it or the right of it, so I was just defaulting to 0.
Okay. Right.
So
Yes.
you need to specify an actual
Margin left. Okay. I could do margin left, and then a special number, right?
And then, yeah, like, well, first I would just put in a random number to see if it works.
I could do that.
So, like,
That's not really the right way to do it, but okay, I'll follow your instructions. All right, let's try this out. Let's go here, and so in my margin, instead of 0 auto, right now we'll go 0 for the top, and then left and right, we'll do something like, how about 25%? Can I do that? Right, it's a little better. Because we don't know how big this is. Auto doesn't mean anything, right? So maybe more. So we'll say maybe you have 33% on both sides, which is probably about right.
you could do it absolute.
Yeah, but I'd rather do this way. So if I change my screen size, then it should move too, right? Which is what I really want. All right, so I've got my thing fairly centered, so we can see it on our screen now. It's okay to do what we did, right? And I did this only because I want it so we can just see it. That's all. That's the reason why it's the way it is, right? Now, in reality, for making a game for to work on any screen, what should we really do? We should let this thing stretch, right? So that the canvas width should be the width of my viewport, right? And the canvas height should be the height of my viewport. Otherwise, if we make it so that it is a fixed width, in other words, 320 wide by 480 tall, it's not going to conform perfectly to your device, right? So how do I do that? How do I make it so that my canvas is going to stretch? It's going to stretch to fit, even though I've done these margins, 33%, right? If I want to, I could make my canvas have the exact size, right? Now, I've defined it inside my index.html here as 320 and 480. And my question is, should I, right? Now, these are unfortunate pixels. That's what they come into. If I put some other value in here, like viewport width, doesn't work in my canvas element, right? For now, though, we're going to leave it alone. I want to leave you with that thought. You can also stretch it later. And we can also change it with code, right? Okay, so now I want to test my game so that it works. And the best way to test my game is some kind of text that says hello world. I'm a hello world kind of guy, right? So how do I do that? And it's also going to set us up for everything else we're going to do, right? Because I need to create two classes. And this is where we start doing TypeScript. I want to make a label class, and I want to make a button class. And you might say, well, Tom, aren't buttons and labels part of Create.js? No, they're not. And that's the beautiful thing about it. Create.js is an API. We build Create.js. There's no built-in functions for buttons and labels. There's text and there's bitmaps, but there's no buttons and labels. And we're going to make those, which gives us a good practice for TypeScript before we get into our player class. And where should those buttons and labels sit? If in our structure, if you look at our scripts, it should sit inside of our objects folder, right? Because buttons and labels are game objects, right? You can also make another folder called UI if you really want to, user interface objects for buttons and labels. But for now, I'm just going to call them all objects. Okay, so first of all, let's kick off the basic library. How does Create.js work? Well, first of all, I need to tap into my canvas element. So I'm going to create a variable. I'm going to use the let keyword. I'm going to create a variable called canvas. I'm going to put it on the global scope. But this is, again, we're in a function. We're in a closure, so we're kind of secure here, right? Which is of type HTML element. Now I'm getting code hinting because of TypeScript, right? So HTML element is the type. I'm not going to define what the canvas is. I'm also going to say that my stage, I need to define a stage for my game where the game is going to play, right? My game stage is going to be using Create.js. Take a look how I'm getting code hinting. You should get this too if you've used my project files. Create.js, oops. I'll be okay. Dot, and then capital S for stage. Oh, Tom. Cool, so I've got this part here. It transpiled. Let's see if it works. It does. Automatically, as soon as I save, it transpiles on save. That's a really cool thing, right? Now that I've set up my my transpilation, right? When I did that, and I did that, by the way, it all gets saved in your a task runner called task.json, which is in your VS Code folder, right? Okay, so this is the two things I need. Now, I'm going to set it up just like we're kind of starting off, and I need a couple functions. So my first function that I'm going to kick off here is going to be called start, right? My function is going to return void. Notice the syntax, right? So my function start is going to return void. This is colon return, the type that it is, right? And then inside my function, I want to kind of make a reference to my stage and my canvas. So I'm going to say stage is equal to new create.js.stage, right? Oh. And then it needs a couple things. It needs an element. This is the code hinting coming into play. It is looking for a canvas element, and that's right here. So I'm going to pass in canvas, right? Now, I need to make a hook to canvas, and we have to do that before the stage. We're going to do that here. So we're going to say canvas is equal to document.getElementById, right? And then in quotations, canvas. Because remember, I called my canvas, I give it an ID of canvas, right? Take a look, just to slow you down, right? Canvas. So canvas is document. I get a reference to my canvas. That's what this is doing. Get reference to canvas element, right? And here I'm creating a new stage object. That's what I'm doing, right? So remember the stage, I want you to think about it as an overlay that overlays on top of my HTML canvas element, right? It's a container where my game will physically live, right? So I need the canvas element as structure, right? I'm using the div tag to position it, right? That's what I'm using for that. And then inside of my canvas, I want you to think about it as an overlay, a little rectangular area. Well, right now it's 320 by 480. Completely the same size as my canvas element is the stage, which is just a game container. Next, I need to define a couple things on my stage. One of them is my ticker. I want to create a game loop. Remember, whenever we do games, I need to refresh the stage a number of times every second. What's the typical refresh rate for any game we play today? Minimum. What would you say? 60 frames you want to target. Sometimes we can't reach 60 frames on devices. 30 is easier to get to, but anywhere between 30 and 60. If I put 60 frames per second as my target frame rate, which is totally cool, the device will attempt to do 60 frames per second, but we may drop frames and go a little bit lower, right? And the way we set that up is we do this. Create.js, we use a static class called the ticker class. And then we want to say is the frame rate, right? Notice I'm getting all the code hinting, I'm just not doing it properly. My frame rate is equal to 60, right? So set FPS to 60. That's what we're doing, frames per second. This is the next step, right? So our frame rate is 60. This is how many times the stage will refresh every second, right? So that means every 16 milliseconds, the stage is going to clear and then redraw everything. It's going to re-render from our buffer memory, right, onto the stage over and over again. It's going to continue to do that. It's going to be so fast that the human eye can't detect the refresh rate, right? It's going to be faster than we can detect it. So it's going to look like smooth, very smooth rendering or drawing. Okay. Next, we need to create an event, right? So we're going to say create.js dot ticker. I want to access the ticker again. Dot on. On is the way we do add event listener with create.js. It actually creates a little a shortcut for us, right? And on, we're listening for a type of listener. The string is the type of thing we're listening for. We're listening for a tick event, right? On tick. We're going to access, what's the handler? We need to access either a callback function or an anonymous function that's inline, right? We don't want to do that. I want to access a callback function called game loop, right? Or, in this case, update, right? We don't have the update function, however, right? We don't have that. And we need to create that as a function. So this thing here calls the update function every frame. That's what it does, all right? Just to give you an idea of how it works. Okay, and then eventually we're going to play the game, right? We're going to call the game function, which I also don't have. Yeah, I don't have these functions yet, but I will, right? But further down, so we got our function called start. I need a function called update, because that's what I've kind of put up here. This is our function update. So function update. And inside our update function, we know we're going to get an event happening, right? Because it is an event handler. So it's going to be, we're going to pass in an event, which is of type create.js. Create.js dot event, right? That's what I want. That's the event that I want. We're going to pass in that value. And then inside of our function, we just want to do stage dot update. Update. I keep on tabbing instead of entering. That's my problem. Right? Stage.update. So my stage.update, what it's going to do is every frame, our update function will be called, right? And in turn, it's going to call the stage update function. So we're going to manually redraw the stage every frame. That's what this does. So this manually refreshes stage. That's what it's going to do, right? When I mean refreshes, redraws, what might be the better word, right? Okay, so that's what it does. Redraws the stage and kind of clears it and redraws every single frame. Now we need our game function. Right? Our game function is going to return void. Probably this will return void too. I forgot to do that. Our game function will return void. And what it's also going to do in here is I want to kind of say our game is started for the beginning. So console log for now, just to make sure that, that game started is here, not at the top. So if we can get to this point, that means everything should be running as normal. We can get rid of this. Okay. It's our little code right now. So what it's going to do is this. It's going to, when start is called. Uh-oh, is start ever called? Remember, the only way it's going to happen, to get this going, start must be called. And I want it to be called as soon as the window loads. So the best way to do this is to have a little window load event at the bottom of our file. So window.load, right? And is that we're going to point to start. Right? So on load, when the window loads, our start event is going to trigger. We can also configure it differently. Instead of window.onload, I could also use window.addEventListener, right? In quotations, load, right? And then comma, and then point to my start. That's another way of writing it. So calls the start function when the window loads. Window finishes loading. Okay. Again, some comments for you guys to understand where everything is happening, right? So then what this should happen is if everything runs properly, when the window loads, it's going to call the start function. It's going to load the canvas, create a reference to the canvas, pass the canvas element to the stage, set the frame rate to 60 frames per second, create an event listener for the tick event. So every frame, it's going to call the update function, and the update function in turn is going to redraw the stage manually, right? That's what's going to happen. And then after this event listener is registered, we're going to call the game object. And even though it's in different times, remember this is happening asynchronously, right? Any kind of event is happening on its own event queue, right? And then what's going to happen is the game function is going to be called, and we're going to see console log game started. So it should say game started, right? So if everything goes well, we shouldn't get any errors, and the game should start. I'm going to save my file, and if I go to game.js, you can see that it's been transpiled and kind of compressed a little bit, so you can see that there's no white spaces between function calls. Now notice this is an anonymous inner function, right? Anonymous self-executing function, or immediately invoked function expression. So you can see that everything is encapsulated. You had a function within a function, right? And we're going to have functions within functions within functions pretty soon. Okay, let's run this thing and see if it works. Well, guess what? We've been running it the whole time, right? We've been running it in the background with our browser sync. And if you look at this, right, we've got this still. It still shows. That's a good sign. If I go to my inspector, I should be able to see game started with the ... because that's how I did it. So we're good to go. My create.js works. So recap before we move on from right now, because we're almost at an hour and a half mark, right, for recording. We set up our project, right? We've kind of created the framework, if you will, that we're going to be using to create our next pieces, the next piece parts to our game, right? And this is again just to demonstrate TypeScript and what's required on the back end when you build your Ionic app, right, from scratch. And the best way to look at this is, how does it work with something else, right? How does TypeScript work? This no Angular, just TypeScript. Because if I mix Angular in TypeScript, it's even more difficult to understand, right? Because then you're looking at two different syntax patterns that we want to look at, right? Okay, but this is really boring. So before we pause for a short break, I want to do my hello world. This is my goal, right? And I want to make it spin 5 degrees every frame, right? So that it kind of shows my hello world right in the middle of my canvas. Now you cannot do this with HTML very easily, yeah? You need some kind of complex CSS and maybe some JavaScript to make it spin around. But it makes it easy with create.js inside my canvas element. Now it will not move out of my canvas element. Anything outside of my canvas element will be ignored. Only inside the canvas element will we redraw anything, right? Just to keep in mind that. Okay, in order for me to do that, I'm going back to my game.ts file. If I'm going to call something that spins, I'm probably going to make it spin inside the update function, because this is where my update is being called for now, right? I don't have another object right now, and I have some basic building blocks. I have something called bitmap, and I have something called text. And those two things I will rasterize any font that I pass into my text and create it as pixels. Okay, just letting you know. So I need a kind of a, and these kind of things right here, this is more of my, I'm going to call this my create.js, right? Create.js variables. These are what I need those two variables to kind of kick off create.js. But then I'm going to have some game variables. Again, we can encapsulate these later. For now, I'm going to call let, and we're going to call this my hello label. I've done this many times, which is of type. Now, this is the great thing. Create.js dot text, right? And notice that it is a type. Now that I've done this and it's create.js.text, I'm going to get good code hinting to do all my stuff on my label, right? Just like you would expect in any major language, C#, Java, whatever. So down in here, what I want to do inside my main or my game, right, is I want to define what my text object looks like. So I'm going to say something like this. So hello label is equal to a new create.js.text object, right? And it looks for a few things. There's some optionals. Notice the question mark is an optional, right? I need a text object, so a string. What is it going to say? In this case, the first one will be hello world, right? And then I need a font. I'm going to use Consolus, a really ugly font, right? So Consolus, I'm maybe going to make it 40 pixels, let's say 40 pixels, Consolus, right? That's my font and my size of my font. And then I need the color of my font. I can leave it blank, but I'm going to put in, again, hexadecimal colors for black. And then I'm going to put in anything else I want to put in as a callback. For now, this is all I need. So this is my hello label. And my hello label, I want you to think about it as a fully fledged object. Okay? It's no longer just a variable. It's an object. It's packed with information, believe it or not. Okay? Now, because my hello label is here, has it been added to the screen somehow? No, I've just created an object. That's all I've done. I need to add this object to the stage. And we have a very simple way of doing that with create.js, which is stage, referencing our stage, dash add child. And if you remember, if you're someone who's ever done Flash before, then this syntax for create.js will be very familiar to you. And the reason why it's very familiar is because the people that worked on create.js, Grant Skinner and company, were the same people who developed Flash. And so if you know Flash, then you're pretty good on create.js already without even knowing it, right? So add child, and then we're going to pass in hello label, right? So what this is going to do is it's going to bind my hello label object to the stage as a child object of the stage. But I want you to think this for whatever reason, if you put it in your mind. The child object, even though it's a text object, is still a container. So I have my stage container, which is the outer container, and I've got my inner container, which is that text. Each container, where is my 0, 0? We're looking at geometry now, right? Where is my 0, 0 for my containers on a computer? Top left, right? So 0, 0 for my stage is top left, X and Y, right? And so too for my label, left X and Y, right? So where would my label by default appear on my stage? Top left, right? So if I save everything, transpile, right? And it did already, transpiled. And if I look back on my stage, you can see that it's on the top left corner of my screen, right? Now you might think that this is nothing special, Tom, because it's just text. No, 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 no. It's rasterized text. This text is pixels. You cannot highlight this text. I cannot select this text. It's nothing to do with it. It's just pixels that have been rendered to the stage, okay? I want to move this down here. I want to center it, but the problem is my focal point is in the top left corner of my object. I want to move my focal point to the middle of my object, so when it spins in the middle, not on the corner, right? And the way to do that, right, in my code is to set something called registration values, right? Don't worry if you don't remember any of this. Hello label.regex. Notice I'm getting, again, without code hinting, that's what TypeScript is helping with right now. I'm pointing it out again because TypeScript is great for tooling, not just for making classes and extending JavaScript. So regex, again, is going to be equal to my hello label dot get measured width, right? That's what I want. Get measured width. And get measured width is a a method, if you hover over it, a method that returns a number, right? So get measured width, the width of my object. I don't want that. I want to multiply that by 0.5 because I want to have half the width. I want to be in the middle for my x component. I want to do the same thing, but instead of get measured width, I want to do get measured height. And I want to use my reg y, or my y value, right? My registration point for my y value is get measured height, right? There it is, times 0.5. Now, if I look at the screen, you can see that my hello world off screen, right? Because it's going to start rendering from that registration point, right? That's where the middle point is going to be. So when I set 0, 0, my x and y coordinates, it's going to be from that registration point. Now, to set my x and y coordinates, I can go hello label.x, and I want to make it half the width and half the height. And for now, my screen, I'm going to hard code this, but we're going to change it later, and maybe in another session. My half my height and half my width is 320, so that means it's going to be 160, right? And my height for my y component is going to be 480, which is 240. So that's the exact center of my screen. And if I go back, you can see now hello world is in the exact center of my screen. Great, I've accomplished one piece, but now I want to make it spin around before we stop recording, right? So how do I do such a thing to make it more interesting? Oops. Well, all this stuff is going to happen inside my stage, like I said, and I want to do it before I update my stage, so it means that I'm going to do it somewhere in here. And I'm going to call the hello label dot rotation. Remember, hello label is packed with information and properties. It has a rotation property, and I'm going to make it so that every frame it changes by 5 degrees. So rotate clockwise 5 degrees every frame. That's what this is going to do. Every frame, that means every 16 milliseconds, 5 degrees. It's going to be pretty fast, right? And now that I've saved and transpiled, if I go back, I'm going to have my spinning hello world, right? Now, again, this might seem like, who cares, Tom? It's easy to do, right? Once we do this, my friends, right, we can do almost anything. And this is why I do a hello world. I do the same hello world if I use SpriteKit, if I do things with Unity, if I do things with Unreal. This is the beginning of what I start doing. All right? I'm going to take a short break, and when we come back, I'm going to put an object. We're going to define 3 objects. I want to make a button object. I want to make a label object, and I want to create the 3rd object, which is going to be my player, that when I move my mouse around, he's going to move around the screen anywhere I want. Okay? We'll do that when we come back from break.